Hello. Hello and good morning. It's hard for me to see you guys, but I'm so happy that for the first time in my conference life, I have a stage that is taller than me. Great. I am here today to talk to you about Orleans, or at least an introduction to Microsoft Orleans. Let's first talk a little bit about me, very short. My name is Johnny. I'm from Belgium. And I basically work as a consultant in .NET. So I'm mostly doing backend .NET development, a little bit of architecture, and I'm just having fun on little side projects. The talk that I'm giving today is available on my GitHub. Everything that I'm talking about, all the examples, but also my PowerPoint slides is already available on my GitHub. So you can just check that out if you want to learn more about it. If you have any questions, of course, at the end of the talk, we can discuss. I will be here for the remainder of the before noon, so you can always ask me questions if you want. And if you didn't have a chance to catch me, you can just contact me on Twitter or use my professional email address. So enough about me. Let's get into Orleans. Now, Microsoft is talking about Orleans this year quite often. I've seen a couple of their presentations, and to be honest, I think their presentations are a little bit too much marketing-y. It's always kind of high level and abstract, and I don't like that. So I decided to do the same talk, but I'm going to give you a practical example, and hopefully you will learn more from this than from a marketing talk. Before I can do that, I have to tell you a little backstory of a personal project that I did many years ago. So in Belgium, we have schools that run at night where adult people can go to learn new things. They maybe can have a new degree to change jobs, stuff like that. I did that for 10 years. From 2009 to 2019, I've been teaching .NET C# to adults. Now, if you need to teach C# to an adult, and you need to keep things simple, what do? You create a console application. Console applications are boring. So I decided to create a game where robots need to fight each other, and players need to write C# code to make their robots do something, which is a perfect thing to learn basic structures. What are variables? What is an if statement? What's a loop? Stuff like that. And you get immediate feedback. When you deploy your code to this arena, you can immediately see if you did something stupid or if you're writing very good code. Now, getting to Orleans. 6 years ago, I did this project. And I made some mistakes. First of all, just to show you, this is what a C# script can look like. So there's no namespaces, there's no classes, there's no methods. There can be, but there don't have to be. So you just basically write a piece of C# that will be executed every 2 seconds. So all the robots on the arena will do this. They will compile and run their C# script every 2 seconds over and over again. So this script will basically make a robot walk around in squares or circles, whatever. Now, as I told you, I made some mistakes in the architecture. So when I first built this, on the top side, there's the front end, which is in Unity. Very simple. I know C#, I should know Unity, so that worked perfectly fine. Now, in order to make the game state visible, I just created an HTTP API using ASP.NET MVC, and this API would just be called every 2 seconds by the Unity frontend. It will just ask, please give me the current game state, and then Unity would render that state every 2 seconds over and over again. Where is that game state coming from? It's coming from a database, a SQL database, because I'm an old school guy. Probably overkill, because there's only one table, but never mind. So the database. Of course, we need to do some processing. And processing is a separate process, which is a .NET Worker service. It will basically get all the data from the database. It will compile all the C# scripts. It will run all the C# scripts, and it will write the state back into the database. So the next time the HTTP API runs, it has the new state. And then, of course, on the right-hand side, we have a website where the player can basically copy-paste its C# code in like a text box that does some color coding. It just clicks a button, deploy to Arena, and it will be written into the database. So very simple concept, but basically flawed. Flawed, why? I tried to do this once for an audience of 100 people. Compiling and running 100 C# scripts in only 2 seconds when you only have one worker service can get a little bit tricky. And also when I run this with students who don't know C#, they make a lot of mistakes. And they make a lot of interesting mistakes that will basically crash my website, crash my processor, and then I'm done. So I made a few adjustments to this. The first adjustment that I made was to create an additional validator service. So when you paste a C# script into the web UI, that C# script will first be sent to a validator. And this validator was a very small application using gRPC communication that would just try to compile your code, and it would try to run your code in a couple of situations. So it will say, okay, let's say there's 4 enemies, they will hunt you down, what are you going to do? So I basically tested the script a little bit to see if there's any infinite loops or if it didn't compile at all. And if it caused unstableness, basically my validator service would crash instead of the rest of my application. So that was the first thing that actually went well. And the cool thing about the validator is I could scale it. I could have multiple validators, and I could have a load balancer before that or in front of that. And if one goes down, there's still others available for the people to work with. But the processor was still something that I did completely wrong. And I didn't have time these past few years to actually make it a scalable processor. And then I heard about Orleans. I heard about Microsoft Orleans, and they promised me that I could use the actor model to create easily scalable distributed applications. So I was like, I want to learn about that, and I want to learn about that by basically rewriting my C# Wars application. And that is what I did. So conceptually, it's still the same thing. We still have the HTTP API, but we lose the SQL database because Orleans has a couple of things that you can use to store state. One of the things that you can use is Azure Storage, more specifically blob storage in Azure. So I decided to throw away the SQL and use Azure Blob Storage to store the state of my game. Then the web UI is still there because we need to use it to input all of the C# scripts. We still have validation, which is now an Orleans silo, and we have the processing, which is also an Orleans silo. And I will talk about those things in just a minute. Now, thanks to this, I can now scale my C# application, C# Wars application. Why? Let's tell you about that. But first, Orleans is based on the virtual actor model, which is kind of old already. It's a simple concept. It basically means that everything your application needs to do is being done by actors. Actors, and one actor is something that does something, but only one thing. It's like the single responsibility principle from Solid. When you build a class, for example, it only needs to have one single responsibility. So it's the same thing for your actors. And actors can interact with each other. So basically, when I build an application, for example, I have actor A, which can call into another actor, which is called actor B. And inside of this actor, we can have a state. And that state can be active in memory, but that actor can also be deactivated, and it can persist its state to some kind of storage. In my case, the blob storage from Azure. But when that actor needs to be reactivated, and I will talk about activation and deactivation also in just a minute, it will just read its state, and it will keep its state back into memory. Now, of course, actors can talk to each other. So when you have all of these actors with their single responsibilities, they can, of course, use each other to basically build the whole of your application. And next to that, you can also have clients that talk to your actors. So you can have a client talking to an actor, that actor can do something, call another actor, that actor can do something, and so on. And because of this, this is the thing that I heard from Microsoft. I was like, this actually seems a good fit for my game, for my C# Wars game. Because if you think about my game and you think about actors, it kind of makes sense. Can somebody guess what a good actor would be in my C# Wars game? Who knows? Who wants to take a guess? What would be a good actor? Nobody? Excuse me? A player. Indeed, that's a good actor. A player basically has a name, and he owns a couple of robots. So a player indeed is a good actor. Anything else? Excuse me? A gun. It's a good idea, indeed, but I don't really work with guns in my game, so I'm not using guns, but a gun would be a good actor. If you have multiple kinds of guns, then each kind of gun can be an actor that you define, and then instances of those actors can be all the guns in game, so very good. Actually, one that I use is the robot itself. So each instance of a robot is also an actor. So these are my actors, and these actors need to work together. And to show you what that can look like, I prepared for you a website where you can deploy a robot into the arena. So if you very quickly scan this QR code or visit web.csharpwars.com, you have a couple of input fields for your player name, for your robot name, and you can select a script template, so you don't have to write a C# yourself. And I just want you to deploy a couple of robots, and then we can see how these will act in the Orleans cluster. Now, this is not HTTPS, I'm very sorry for that. So look out for the HTTP. I didn't have time to get the certificate. But yeah, I created a couple of grains, or actors, and those will all work together. And the cool thing about this in the Orleans cluster environment that you basically set up is that these actors will basically be put on an instance of your application. If you have multiple instances, these actors will be spread among all of those instances. So it's basically scalable by default. I can have my processor instance, I can have 4 or 5 or 6 instances, and my grains will just be spread around all of those instances. So when I play this game with 1,000 people, which basically would make my arena a lot larger, but it wouldn't be an issue when I just have enough instances to compile and run all of that C# code. So let's see if somebody actually did something, and it looks like you guys did. So these are now a bunch of robots fighting each other. I hope nobody used swear words in their names. But it seems that most of you like ranged attacks. So now I have this going on. Every 2 seconds, the scripts will be compiled, and they will be run, and the state will be saved into my actors. So let's go back to a little bit of theory then. In Orleans specifically, because the actor model is something quite old already, and there's multiple frameworks that basically work with the concept of the actor model. For example, Akka or Akka.net does the same thing. Orleans is just another implementation of the actor model. And in Orleans, they use specific naming conventions. So an actor in Orleans is called a grain, like a grain of salt, so just a grain. And a grain is always identifiable, which means, for example, my player grain, which you told me about, has an identity that will specify who is this grain and how can I talk to this grain. And this is based on a name. For example, I have a player/Johnny, which would be my nickname, will be an identifiable player grain. Then we have a behavior. My grain will do something. So you basically write a class that implements from an interface that has a couple of methods or things that your grain needs to do. This is your behavior. And then optionally, not all grains need state, but optionally a grain can have a state. And that state is an in-memory or persisted representation of the data that needs to be stored as part of that grain. For example, a player has the identity player Johnny. It has the behavior that a player can create a robot. And it has the in-memory state which contains the name of the player, which is basically the only state that a player needs. So this is a grain. Now, as I said, grains have this identity. So when you call a grain, you will get the grain with that identity. It can persist its state. And the cool thing about grains is when you call a method on a grain, it will do something. But you can also have timers and reminders. So you can have your grain basically work on a timer and do something every couple of milliseconds, seconds, hours, whatever. So instead of calling into a grain, you can make your grains do something on a timer. There's also things like grain placement, which I will talk about a little bit later. I told you about the fact that grains will be spread around all of your instances within your Orleans cluster. You can, as a developer, specify where your grain needs to be placed. But I'll show you an example in a minute. And then there's activation and garbage collection. Now, if your grain is not used for a long period of time, it will be garbage collected. So it will basically persist its state, and it will be taken down. Your grain still exists because the state is stored in your, in this case, Azure Blob Storage, but the grain itself does not live in memory anymore, so it doesn't use resources. And then when you call into that grain, and that grain does not exist, well, it still exists. That's why it's a virtual actor model. It will just be activated again. It will read its state from persistence, and it will be available to you again. So let's show you when I go into my website for C#Wars. When you use Orleans, you can optionally add an Orleans dashboard to your application. This is actually not to be used in production because it uses a lot of resources to look at what your grains are actually doing. But it is a good thing to learn from and to debug and to check what your Orleans cluster is actually doing. First of all, you have an overview, which just tells you how many grains are activated, in this case 161. It has an error rate, so if there's exceptions somewhere in your code, it will show you an error rate. So I have a very small error rate, it seems. The amount of requests per second that we can do, and activated silos is how many silos. I will talk about silos again a little bit later. Now, if you look at grains, you can see all of the different grains that I basically defined and specified. So there is indeed the player grain, and there are 72 players. So 72 of you created a unique player. And then there's 40 robots. So 40 robots are deployed, and there's also 39 because a robot has died just now. So there's also 39 scripts, 38, another robot has died. So you can see that all of these things are put into separate grains. There's also one arena grain, by the way. The entire arena is also one grain, so I can have multiple parallel arenas if I want. If you look at the same thing in code, is this big enough? Should be. You can see that there's a web API, of course, and then there's the website, and then all the way in the bottom, there's all the Orleans projects. So an Orleans cluster, when you build your Orleans application, it needs a host. It's a host application that will basically host an instance of your silo inside of your cluster. So I created two hosts. There's the normal host, and there's the validation host. First, the normal host is a project which actually contains little code. It only has that program.cs file that uses the host builder, just like your ASP.NET application does. But it uses a method called useOrleans. And in useOrleans, you specify what your Orleans cluster and silos need to look like. I have a connection string to my Azure storage. I use some application insights to do logging. And then I have two specific situations. If I'm debugging, so if I just press run in Visual Studio, I'm going to use performance counters. So the performance counters are actually used when you open up a silo, so one instance of my host application. It will give me information about CPU usage, memory usage, and so on. So this is something you can do using the performance counters. And then you configure your endpoints. So your silo that contains all of your grains needs some ports to do communication between different silos. Now, if I'm not debugging, I'm just doing the same thing, but I'm doing it in Kubernetes. So I'm basically hosting the thing that you see, the thing that you used, like 72 people have actually created a robot or a player. This runs in a Kubernetes cluster environment. So Orleans also has a couple of NuGet packages that you can use to deploy into Kubernetes, for example, but also in other kinds of environments. And then you specify your cluster ID, just a unique ID that will define the whole of your cluster. And that's it. That's it. You need to specify some other things for application insights, for logging. I have specific blob storage files to store all of my grain state. And that should be it. Now, next to your host, you of course need to define your grains. Now, I have a separate project containing my actual grains. Here you can see arena grain, bot grain, messages grain, moves grain, player grain, and so on. So if I, for example, open the arena grain, you can see that arena grain is a class that implements from the iArenaGrain interface, which defines all of your methods. And then there's the grain base of iArenaGrain. Now, grain base is a class that I wrote myself, which actually implements, derives from the Orleans grain class. So this is the base class in Orleans for a grain. You need to derive from that, and then you need to create that interface. Now, if you look at that interface, it needs to implement an Orleans interface that specifies what the identity of your grain is built out of. You can have multiple kinds of identities. And now this is something that will change in the future because now I'm using Orleans 3. Orleans 3 is the current version of Orleans. Somewhere this year, I think, Orleans 4 will come out. And in Orleans 4, there will only be one kind of identity, which will always be a string. Today in Orleans, you can have a long, you can have a GUID, you can have a string, so you can basically choose what kind of identity you want to use. For example, for players, I'm using the string identity because a player has a name. For robots, I use a GUID because every robot that you create will just get a random GUID as its identity. So you need to choose. So my arena grain, for example, has a couple of behaviors, like get all of the active robots, get all of the alive robots, get the details for the entire arena, create a robot, delete an arena, and delete a robot. So these are the behaviors that you then need to implement. Now, if you have a client, or if you have a grain that needs to talk to another grain, this is where things become very easy in Orleans. You have multiple grains, you want to talk from one grain to the other, you just do the method call. You don't need to think about, do I need to do HTTP, or do I need to use gRPC or something else to talk between these grains that can actually live in separate hosted environments? No, you just call the method from the interface. And this makes my life as a developer very easy. For example, if I look at the web API, my web API has a couple of endpoints. Also, that endpoint that actually is being called by my Unity client, which does get all of the active robots inside of an arena. Now, in my endpoints, I never write a lot of code. I just forward to something that is called a manager class. And inside of the manager class, I have that method called getAllActiveRobots. So inside of my manager class, I need to basically call into my Orleans cluster into one of those grains. So I created a little helper method that basically uses a grain client. And your grain client is something that you can use from wherever you want. Are you writing a web application? Are you writing a WinForms application? Doesn't really matter. You can have a grain client that can call into your Orleans cluster. Now, this grain client, the only thing it needs is, of course, the address. Where is your Orleans cluster actually hosted? And it needs a port. Which port can I use to enter my cluster? And the name of the cluster. When you do that, in this case, because it's a helper method, you actually use this kind of Orleans method. So you have your cluster client, you do get grain, and you specify the grain interface. So if I want to talk to the arena, I just use iArenaGrain. So iArenaGrain, now you get an instance of a client that can talk to the arena grain, and you just call methods. Just call the method on top of your grain. Very easy. Again, you don't need to think about HTTP, gRPC, whatever. Doesn't really matter. How does this work? Well, when you compile and run your Orleans application, a lot of code generation will be applied. Orleans will generate all of the code for client-server communication to make your application actually do all of those things. You don't need to think about that. Orleans will do it for you. And also in the next version of Orleans, they will have made some modifications to make it more performant, because today it uses HTTP, but I think in the next version it will use gRPC to do the actual communication between grains and from clients to grains. Also, when you want to talk from one grain to the other, it's the exact same thing. If I look inside of my arena grain, when I get all of the robots, I'm going to use a grain factory. And with instead of a grain client, I'm using a grain factory. But conceptually, it's the same thing. I'm just asking for a robot grain, and I'm calling the method getState on that robot grain to get that state. Again, not very hard to do. Now, let's look at silos. Now, I talked to you about Orleans clusters. So when you create a host application, you need to specify what the name of your cluster is going to be. And you can have multiple hosts within the same cluster. Again, I will talk about that in just a moment. But when you create multiple instances of the same host application, you basically create multiple silos. And grains will be activated in one of those silos. And this is also something that you see when you open that Orleans dashboard. So when I go to grains, you can see that I have multiple activations for these grains. And if you click silos, you can see all of the silos that I'm currently running. In total, there's 6 silos. If you look at the silo names, you can see that 4 of them have the host name, and 2 of them have the validation host name. So this should already ring a bell, because I talked to you about the fact that I do validation beforehand. So I'm running 2 instances that only do validation, and I'm running 4 instances that do the actual processing. So these grains are activated on these silos, and you can see on the right-hand side how many activations that are running. On the validation host, there's no activations, because nobody is currently deploying any robots. If you would deploy a robot, it will be activated very shortly on one of those 2 validation hosts. It will do its job, and then it will be recycled because the validation is over. These grains will not stay alive. Now, on the other hosts, or the other silos, these are your robots that are currently alive, and they are actually every 2 seconds processing their data. So they are still activated, and you can see that there's about 40 activations for each silo. If you add multiple silos, the grains will basically be spread around all of your hosts, which is a cool thing. If you click on one of these hosts, for example, this one, you can see the CPU usage and the memory usage for that specific host. And you can see all the methods that are being called, the number of requests per second, the failed requests, and the average latency in milliseconds for each request. And then in the bottom, you can see the actual grains that are activated. And if you look carefully, you can also see that the script and the robot grains, they have the same number of activations. And this is due to the fact that I used grain placement. So if you look at the code for my script grain, so basically, let me explain very quickly. I have my robot, and my robot needs to compile C# code, and it needs to run C# code. This will take some time. Because it takes some time, I decided to create a separate grain that does the actual processing. Why? This is a very important thing. In Orleans, every grain is single-threaded, which means if you call into a grain, nobody else can call into that grain at the same time. Why? Because state becomes very easy when there's no parallelism. When nobody can do something at the same time, you don't need to bother about locking the state. And this is why Orleans is built like that. If somebody calls into your grain, nobody else can call into it at the same time. It needs to wait before the previous call has finished. This is why I created a separate grain for my scripting, because when my robot is basically compiling and running the script and somebody else is asking for what is your current situation, it cannot answer that question because it's still busy processing all of that C# code. So that's why I created a separate grain. So the script grain will do all the processing, and the robot grain will just hold the state and then the link to the script grain. But also, on top of my script grain class, I put the attribute prefer local placement, which means that if somebody calls into my script grain, I would like my script grain to be activated at the same silo as the caller. So in this case, the robot, when it's created or activated, it will basically create the script grain, and the script grain will always be created on the same silo, or it will try to create it on the same silo as the robot. Why would that be a good thing? Well, because when you communicate between grains, communication will be more performant, faster, if they live on the same silo, because when they live on the same silo, the same host, it can just communicate in memory. But when your grain lives on another silo, it needs to do some kind of over a network communication. So it needs to use, for example, HTTP or gRPC to do the actual communication. So when grains are heavily discussing things with each other, it's a good thing that they live in the same host, because things will basically be more performant. And this is one of the attributes that you can use to decide where your grains are placed. So in my case, robots and scripts will always be placed on the same silo. Back to this one. So this is why the number of activations are almost always the same value, because they will basically talk to each other a lot. And that's also why the milliseconds per request are quite low in this case. Another thing that I forgot to talk about is timers. Now, in my case, my processing happens every 2 seconds. So something needs to tell my script grains to process every 2 seconds their scripts. So you can have a grain that has a timer. So I have my processing grain right here. My processing grain, there's always one instance of a processing grain per arena. So each arena has a processing grain. And that processing grain will just talk to all of the other grains that it needs to do the actual processing. And in this case, when you activate your grain, you will register a timer that will start in 30 seconds. So when you start your silo and you activate your grain, it will take 30 seconds to initialize, which is basically for my debugging purposes, so that I can wait, that I have 30 seconds to start all of my debugging processes, and then it will run my timer every 2 seconds. And every 2 seconds, the method onTimer will be called. So this grain will basically call into itself every 2 seconds, and every 2 seconds it does its behavior. Now, the weird thing about these timers is the fact that they don't really look into garbage collecting. I told you, when a grain has nothing communicating with it, it will be garbage collected and it will be deactivated. Now, you would think when you use a timer like this that the grain is active every 2 seconds so that it will not be garbage collected. But that's not true. Orleans will not see this as communication. The grain itself is processing every 2 seconds, but if nothing from the outside world or from another grain is actively communicating with my processing grain, it will be garbage collecting and my process will stop working. And this is actually why whenever my client, so my web API manager, arena manager, calls into my arena to get the arena details, it will do an additional call to my processing grain, and it will ping my processing grain, which I thought was something weird. Okay, I need to keep my processing grain active, so I'm just going to ping it whenever a client calls in to get me the arena details. And because my Unity client is actively doing that, that's a very nice name, by the way, because my arena my Unity client is every 2 seconds calling into that method. Every 2 seconds I am pinging that processing grain. It will stay active and it will not be garbage collecting, which actually has a cool side effect. When I close this Unity client and when we all go home tonight, after some time, the processing grain will be recycled, it will be deactivated, and all of the other grains that it's communicating with will also be deactivated. So in a couple of hours, my entire Orleans cluster will be sleeping. Until I open this client application again, it will activate my arena grain. The arena grain will be activated. It will activate the processing grain because it's pinging the processing grain. It will register its timer and the whole process will start up and my game will start working again. So whenever I'm not using it, by default, automatically, my cluster will go silent. And I can basically automatically downscale it so that it doesn't use too many resources, which I think is a cool side effect. Now, as you see here, I built multiple of these silos, and in each silo, all of my grains can be activated. My script, my bots, my arenas, my players, but then of course I have those specific silos for validation, and only the validation grains can be activated in those silos, but they belong to the same cluster. So this is also a functionality in Orleans that I find very interesting, which is called heterogeneous silos. I hope I pronounced that correctly, heterogeneous. So when you create multiple hosts, you can basically specify which grains can be activated in which hosts. How do you do that? Well, in this case, I have two hosts. I have my host, my regular host, and my validation host. I already talked to you about that. But then I have grains, and I have validation grains. So all of my regular grains live inside of this project, and all of my validation grains live in this project, which is only one. It's only the validation grain itself. And as I already told you, when you call the validate method, it will do some simulations, it will compile and run your script, and when it's done, it will actually call deactivate on idle. So you can, from within your grain, you can deactivate yourself. You can say, okay, whenever this method call is finished, deactivate me because I'm not useful anymore. And then the next call into that grain will activate a new grain for new validation purposes. So that's why these silos are actually quite silent. They're only activating grains when it's necessary. But when you run this application, you will get runtime errors because all of your silos, all of your hosts, they need to know about all of the grains. But in this case, I specified that these grains belong to the regular host and this grain belongs to the validation host. So you basically need a separate project containing all of your grain contracts. So all of your interfaces are shared among all of your hosts. But then the actual implementation for your grains, they are only referenced in the host where you want them to be activated. And then Orleans automatically knows, okay, I know about all of the grains, but I only know these implementations, so only these implementations can be activated on me as a silo, which is something I found rather interesting, because now I can specify which grains I want to run on which silos, which is, I think, very cool. Now, let's go back to the PowerPoint. Yep. Now, finally, how did I deploy this? Now, I'm using AKS, or Azure Kubernetes Service, because I think it's an interesting thing that I can show you about the scaling of this. Now I have my host, I have my validation host, I have my web page, and I have my web API. So 4 projects that I should basically deploy to an environment. What I did was create Docker containers for them. So I created 4 Docker files. So one for the host, one for the validation host, one for the website, and one for the web API. I built those containers. I put those containers on a container registry, which lives on Azure. And now I can deploy them to Kubernetes. So this is a view on my Kubernetes cluster. On the left-hand side, you can see all of my deployments, which I already expanded. So there's 4 deployments. There's the Orleans host deployment, which has 4 instances running. There's the Orleans validation host, which has 2 instances running. There's the web, which only has 1 instance, and there's the web API, which has 1 instance. So if you look at the Orleans dashboard and you look at silos, you can see exactly this. You can see the names actually correspond to those pods in Kubernetes. So in Kubernetes, you have your pod names, which correspond with the ones you see in the Orleans dashboard. Now, if I would change this, this deployment, and for example, tell it that I only need 2 replicas. Replicas means instances of my pod. And I would save and apply this to my cluster. Kubernetes will basically kill off 2 of those instances. Sometimes it takes a couple of seconds or even minutes, but now 2 of those instances will be recycled. They will be gone, and I only will have 2 of them remaining. So as I said, it sometimes takes some time. So let's refresh. There's they're gone. So now I only have 2. And if you look at your cluster, or I'm sorry, your dashboard, you can now also see that 2 of those disappeared. The cool thing is your activations will actually be spread around and will get assigned to a new silo, to a new host. So you can see it was changing now. Now you have 67 activation on one and 32 on the other. So spread around is not exactly a good word here. But then when you start playing again, they will get more even as the time goes on. If you do it the other way around, you go back to your deployment. That's to make sure, close some of them down. Go back to my deployment. And let's say I want 5 replicas applied to my Kubernetes cluster. They will now quickly appear. And they also will automatically be found by the Orleans cluster, and they will show up here. On the right-hand side, you can also see that there's them running for 50 minutes, and then the bottom 3 are running for 30 seconds. So those are the 3 new ones, and then activations will be activated on those hosts. As you can see, there's also already 4 activations on the first one, and as time goes on, they will be spread around all of those. Now, again, a cool thing about Orleans is you don't really have to do a lot to make this work. If you looked at the host code, so the actual host code, the only thing that it really contains is that the fact that you are using Kubernetes hosting, and you need to specify a cluster ID and a service ID, which is just a string. So if you have multiple instances, multiple pods running a host that says that it needs to use Kubernetes hosting, and it has the same cluster ID, your Kubernetes cluster automatically knows that it's part of its cluster, and it will use that as a new silo, and it will activate grains on that silo as long as it has a reference to those interfaces for your grains. By the way, if you run this locally on your local machine, it works the same way. I have 2 host applications. If you just press start, I basically have multiple startup projects. It's the API, the website, and then the 2 Orleans hosts. It will work just in the same way. It will start your 2 hosts. They will immediately see each other, and they will know that you have your cluster containing 1 instance of the regular host and 1 instance of the validation host. It will, of course, take some time. Now, working on this example actually made me learn a lot about Orleans. Again, when looking at the presentations, I was like, okay, I think it's a good idea, but I don't really see the application. For this game, the application for me is entirely clear. When I play this game with 3 people, I only need 1 host. When I play this game with 100 people and I have multiple arenas, I can just scale up very easily in my Kubernetes cluster, just have more replicas, and it will work just fine. Okay, also, when I run this, I also need to basically start my Azure storage local environment because it connects to my storage locally. Let's try that again. So I would see a good use case for Orleans when you do a lot of processing inside of your business logic and when you need to very easily scale this, that you have multiple instances. You don't need to worry about things like queues and subscriptions. You can just have your actors that do their single responsibility thing. They do their behavior. They can talk to each other and so on. So you don't have to worry about communication in between of your services, just to communication between grains. And as a C# developer, we know how that works. Just call a method, pass some arguments, and you're done. This is also the reason why in Orleans, all of your methods inside of your grains need to be asynchronous. They need to be asynchronous even if there's nothing asynchronous to do. If you just need to change a value for your state, you always need to return a task. Because the code generation for Orleans will basically need the asynchronous fact to create the actual communication over the network. So it needs to add code from that. So now it's running on my local host. This is my API. This is my website, the one that you opened just earlier. And these are my two silos. Also, if I change this port to 8080, this is my Orleans dashboard, which I'm running locally. As I promised you, I have those two silos, one for validation and then the other one. So you can very easily debug. You can put breakpoints inside of your grains when you do something, and they will hit. If you throw an exception in one grain when it's being called from another grain and you don't catch it, the exception will actually happen where you call it in that other grain. So all of the networking in between to make that work, to transfer the exception details from one host to the other host, everything is done automatically for you. So debugging becomes very easy also. Now, what else do I need to show you? Yes. As you've seen earlier also, I'm using blob storage for the state in my grains. So if you open the Azure Storage Explorer and you look into your actual storage account, so I'm using my storage account C#wars, which has some blob containers, which has grain state, and I refresh, you can basically see the identity of all of my grains. And for each grain activation, so for each instance of a grain, there is a JSON document. So this is like document storage. I'm just storing the state for each grain inside of a JSON document. And the name of the document is the identity of your grain. So it's always, if you, for example, I told you a robot uses a GUID. So this is the GUID that I'm using for my robots. If I scroll down, the player actually uses the player name, which is this one at the end. This is the player name, which is part of that identity. And if I, for example, look at one of these players and I download the document, you can just read all of the state within that JSON document. There we go. So this is the state, which is the type, where the type lives. It exists equals true. That's a property that I use. There's the username. There's the password hash, because you basically you didn't create a password. I just simplified the website. But normally, when you play this game, you first need to create a user with a password. It's hashed. It's salted. So all of this information is stored within that player grain. Okay, there's the last deployment. You basically cannot create robots in rapid succession, so you always need to wait a couple of minutes before you can create a second robot to make sure that you guys don't overcrowd my arena. And then you have all of the robot IDs. I also, per player, keep all of the robot IDs. So this is that state that you can also easily look into. Another thing that you can do in Orleans is tell it where to store all of the information about the entire cluster. By default, it will do that in memory, which is good enough. Basically, whenever there's a host alive, there's a silo alive, it will keep a copy of the entire cluster configuration. It will know how many silos are there, which grains are activated in which silo, and so on. But you can also specify to store that out of memory. And I just tried to store it in table storage. So if I look in table storage, there's Orleans silo instances. This is basically a table that has a reference to all of the silos and all of the information that it needs with that. Which silos are dead, which are alive, which are current, which are old, and stuff like that. So again, all options that you can do with these kinds of statements. So use Azure Storage Clustering, which will use a connection string to store all of its clustering information. And with that, I think I did everything. Yeah, this is something I didn't talk about. This is basically the garbage collecting of grains. So you can specify how long it takes for a grain to be deactivated by a garbage collector or a grain collector. So collection age is a grain will be collected when it's older than 10 minutes and has not been called for those 10 minutes. So then it will be garbage collected. Then there's collection quantum, which basically tells the collector at what intervals it needs to do its work. So every 5 minutes, the grain collector will look at all of the grains, and all of the grains that have been older than 10 minutes and have no active calls within those 10-minute time frame will be garbage collected. They will be deactivated, their state will be written into my blob storage, and they will disappear. And that's it. With this, I am at the end of my presentation, so I do still have some time for questions. So I'm not sure if there are any questions. Yes? Yes. I didn't look into it, but there is indeed versioning of grains. So you can also do this with attributes on top of your grains. So you can have multiple implementations for the same grain interface, and you can have attributes based on which version of that grain you're working with. I haven't tried it out, so I can't really explain how that would work, but it does exist, so you can do it. I'm sure of that. Any other questions? Yes. No. Basically, those grains will die, but their state will be saved. Not per se. It could be that their state will not be saved, but you as a developer can also save that state on specific actions. So what I do, for example, and I can show you very quickly, whenever something changes within that state, I will always call a helper method from Orleans that will save that state. So if I go to my grains, my robot grain, for example, and I go to, let's say, create robot, then you can see that there's a call to write state async. So this call will make sure that that state is written to storage. Now, when I kill that instance, the silo gets destroyed. The grain will not be not be deactivated if you kill it, but the state will hopefully be stored because I stored it beforehand. And then when Orleans sees that that grain is not there anymore, it will not reactivate it automatically. It's basically when another grain or a client calls into your grain that the Orleans cluster will see, okay, this grain has not been activated anywhere because it's gone. So it will reactivate it, it will read the state from memory, and everything will still work.
But if it's a vital grain like your timer, so the application will stop working for a while.
Yes, yeah, exactly. So indeed, if it's my timer grain, it will basically stop working until that arena manager calls that ping method. That ping method will activate. Then it will take those 30 seconds, because I specified it. It will take those 30 seconds to restart the actual processing. So that's correct. Was that an answer to your question?
Yeah, thank you.
Any other questions? I'm going to pick the one on top of you first. Yeah, you. Okay, so the question was, if I would want some statistical information about the game itself, would Orleans be a good idea to do that? I think so, yes. What I do today, which I didn't show you, I have a moves grain and I have a messages grain. Moves basically is a grain that keeps the last 25 moves that anyone within the arena made. So I'm using that for statistic purposes. I'm basically writing it to that grain every 2 seconds what is happening. So you can do whatever with a grain that you want. So you can have statistic grains and have all statistic information within that.
But wouldn't it be all the time persisted, and each time you will need a report, and you will have to query a lot of grains from database, which will basically slow?
So yeah, your question was, won't it be slow if I store a lot of these statistics into a database? I'm using Azure storage right now, but when your grains are active, your grains are in memory and their state will be in memory. When you write a state to your blob storage, you need to wait some time, especially when it's a lot of data. But you don't have to do that. If it's purely statistics, maybe you don't want to store it, or you want to store only a very small aggregated piece of those statistics. But you can keep some of those statistics just in memory, and then it will be very, very quick, and then you can optimize basically your statistics. You also had a question? So your question is, can we have a cleanup action for a player, for example? Well, I actually created that. I created if I understand your question correctly, I created inside of my player endpoints and my player manager a delete all players. Well, there's no delete player, there's delete all players. And I did it like this. I call into my, which is this? My player grain. And in my player grain, sorry, players grain. So yeah, I have a player grain, which is an instance for each player, and I have one players grain. And this players grain keeps all of the players in its state, and it will just for each all of the players, it will then get the grain for that player, and it will call delete player. And then that grain has a link to all of the robot grains, and it will call delete robot on all the robot grains. And then the robot grain has a link to the script, so it will call the script, and it calls delete the script. And because you can deactivate or when a grain is idle, all of those methods will basically call deactivate on idle, so all of those grains will be recycled automatically. So if I would call into that endpoint right now, I do have a couple of minutes remaining, so I can do that. So from Postman, I just have all of my endpoints defined, so I should be able to call into the cleanup. So let's first log in, because I need a token. Let's say, don't really care. So this is my token. And then I can do delete all players. No, this one. Sorry. I don't have a delete all players for my Orleans cluster, so I have to create one. What? How is Notepad slow? What is this? Okay, never mind. So let's duplicate this one. Let's use the correct URI. Yes. Now I need that. I'm sorry, computers are hard. Like this. Send it, and then hopefully it will work, and we should see, fingers crossed, all of those grains disappearing after some time. That's a good demo. It's still running. That's not a good sign, but it should work. I've used it in the past. So now, basically, what you should see is that those grains will start disappearing because I'm just cleaning everything up. But I have to do it manually for now. I'm sorry, it seems that it's not working. Any other questions? Yes? Can you repeat your question? Sorry, I can't understand you with the noise behind me. Let's come stand next to you.
If you have to do something transactional where it involves multiple grains or actions,
yeah,
and you might have to do a rollback, is there a good way?
So your question was, what if I need to do something transactional, and when I'm halfway through calling all of these grains, what if I want to roll back? The answer for me is I have no idea. I've not tried, so I have no idea. I think I read something inside of the documentation about transactions, so I think there will exist something, but I haven't tried it, so I can't answer your question. Sorry. Any other questions? There's a lot of light. If there's no more questions, I would like to say thank you, enjoy the rest of your day, and hopefully see you somewhere in the future.